All right, we're taking a look here at number 5. This is the 2015 question. And it's telling us here that this is the figure of the graph of f prime. So I always circle that to make sure I don't confuse myself. Sometimes they'll give you f, sometimes f prime, sometimes f double prime. Most of the time on FRQs, it's f prime that they're giving you. The derivative of a twice differentiable function. So the function itself doesn't have any issues with continuity or any corners or breaks in the graph there. And it's going from -3 to 4. It has horizontal tangents at -1, at 1, and at 3. So those are where our maxes and mins are, our local maxes and mins. And the area of the region bounded by the x-axis in the graph from -2 to 1 and 1 to 4 are 9 and 12. So it's telling us that the area from -2 to 1 here would have an area of 9. Now it's below the x-axis, so you might think, oh, that should be -9. The area is still 9. But if I was doing the integral, which maybe I'll write this here, if I'm doing the integral from -2 to 1, that integral is actually, and this would be of f prime here, that's actually going to equal -9 because it's below the x-axis. Same idea with from 1 to 4, okay? So find all x coordinates at which f has a relative maximum. So a relative maximum is going to occur when the derivative, so let's write this down, relative or local maximums, I'm just using the wording that they use here, occur when the derivative changes from, so when f prime changes from, and let's think about this for a second. If we want a maximum, we want it changing, the function itself changing from increasing to decreasing. Then we're going to have a maximum at the top of that. So we would want the derivative or the slope to change from positive to negative. And this is justifying it. And it's also helping me organize my thoughts here. So f prime changes from positive to negative. This is f prime. It's changing from positive to negative at x equals -2. And it says find all x coordinates, so that should be the only x coordinate where that occurs. Now if I check the key here, the key says identifies x equals -2 and then the answer with the reason. So you might check more than one spot. Sometimes people go, okay, I'm going to look at all the spots where I have it hit 0. So the derivative equals 0 at all of these spots, but really the only one that super matters here is picking -2. And the derivative changes from positive to negative at x equals -2. So therefore there's a relative maximum at that spot. And we can't have relative maxes or mins at endpoints. So I wouldn't even consider those endpoints because it might end up confusing you anyway. Let's delete that. Okay, so now part B. Part B says, on what open intervals contained in our graph above, the -3 to 4, is the graph of f both concave down and decreasing? So I'm going to start with decreasing. So we know that it's going to be decreasing, and we're talking about the graph of f. So f is decreasing when f prime is less than 0. So it would be decreasing from -2 to 1 and then from 1 to 4. And some people, and even maybe the key, will say that's from -2 to 4. At that specific spot, it's not technically decreasing. There's a little bit of a horizontal tangent. For some reason, AP a lot of times will kind of scale over that and they'll just say, oh, it's the entire interval from -2 to 4. I always say, okay, it breaks there because it's not decreasing at that spot. And that's part of it here. The other part we need is f is concave down. When it would be our second derivative is less than 0. And our second derivative would be the derivative of this graph. So that would be the slope of f prime from above is less than 0 or negative. So if we're looking at the slopes of this graph, when are the slopes of this graph negative? So the slopes would be negative from -3 to -1. The slope's negative, it goes down there. And then the slope's also negative from 1 to 3. So if I'm kind of highlighting this, because sometimes it's still easy to get confused, I know from here to here, it's concave down, and from here to here, it's concave down. And then I know it's decreasing from -2 to 1, and from 1 to 4. So the question is asking, when is the graph both concave down and decreasing? So then I would say, therefore, f is both concave down and decreasing from, I scrolled a little too far here, from this where it's overlapping from -2 to -1, or on the intervals from -2 to -1, and then from 1 to 3. Then glancing at my answers here, I pulled them over. The graph of f is concave down and decreasing from -2 to -1 and 1 to 3 because f prime is decreasing and negative. So they kind of went with wording this a little bit differently. They said f prime is decreasing, which is us saying f double prime is less than 0, or the slope of f is less than 0. That's the same as saying this, so you could word it that way. And then it's negative, f prime is negative, which is what we wrote here. F prime is less than 0. So their justification is really the same. You can word it differently, but you have to be super careful. Do not interchange decreasing with the word negative. That's not the same. And then we'll go ahead and look at part C. All right, just got us a clean page here. So for part C, it says find the x coordinates of all points of inflection for the graph. Give a reason for your answer. So when it's asking for a reason for my answer, I'm going to write what I know about points of inflection. So we're going to have a point of inflection occur when the second derivative, so f double prime, changes sign, because it's when it changes from concave up to concave down or concave down to concave up. That happens when the second derivative changes sign. And the second derivative is the slopes of this. So I'm going to write that. So when f prime, or when the slopes of f prime change sign. Okay, so I'm thinking of the slopes of this graph. So the slope is negative here and then positive here. So we should have a point of inflection at this spot. The slope's positive, then negative. So we should have one here, and then same idea here. So we should have at x equals, and I think it says x, find the x coordinates. Yep, x equals -1, x equals 1, and x equals 3. And I think I have everything I need there. Occur when the second derivative changes signs, when the slopes of f prime change sign. So let's check our answer here. So identifies -1, 1, and 3. So we got our first point for sure, and then the reason. The graph of f has a point of inflection, blah, blah, blah. Okay, because the derivative changes from decreasing to increasing at these points. So when the slopes of f prime change sign. So it's the same thing as what we have, same idea with that. So we got all our points there. All right, then looking at part D. Part D is talking about what's given us an initial condition. And it's asking us, write an expression for f of x that involves an integral. Now remember, it gives us these areas here. It says this area is 9, this area is 12. So we're probably going to use that. We haven't used that yet. And we're given that f of 1 is equal to 3. So for part D, I'm going to work through it up here. Given that f of 1 is 3, write an expression for f of x that involves an integral. So let's say before well, we could start with f of x, that's fine. This is something I've talked about in other recordings, but you maybe haven't watched this part in any of them. Let's say I'm trying to find what I'm going to write this right below it here. Let's say I'm trying to find f of 4, which is one of the things that I'm going to have to do anyway. If I want to find what f of 4 is here, and I know f of 1 here is 3. So I'm starting with a value of 3. And then I have to add the integral going from 1 to 4. And this could be a t or an x. I don't think that's a big deal. It says that it's going to be for f of x. So this will end up being f of x. I would leave t's in here, otherwise it's going to get you confused. So I'm going to go like this. And what I'm going to end up doing here is if I start with 3 at this spot, I'm going to subtract 12 because I know the integral from 1 to 4. I know this area is 12, but it's below the axis. So we'd be subtracting 12. So we get -9. So our f of 4 is going to be -9. And you might be able to do this. And then if you kind of write it out like this, you'll be able to get back to here. So if we're trying to find our f of x, we're going to start with 3 for all of these, because that's the given like initial starting point. And then I know I'm going to be starting with my 1 because it occurs when our x is equal to 1. And I'm going to go to whatever this x value is here. So I'm going to put x at the top of that integral. And then I'm using f prime of t because I don't want to use f prime of x because we already have the x up there. So this would be my expression for f of x that involves an integral. I found my f of 4, and then I have to find f of -2. And a lot of times when people go backwards, they end up messing it up because it's like, oh, it's below the x-axis, so I have to subtract. But then you're also going backwards, and when you end up with multiple negatives going on, it's super easy to mess up. So I am just going to use what I wrote here to write what f of -2 is going to be. So I've got my 3 to start with, and then I'm going from 1 to -2 of my graph that I see there. F prime is just this graph. And a lot of you might want to flip this because it makes a lot more sense to flip it a lot of the time. So if I want to flip the integral, I have to change this positive to a negative, and then I'm going from -2 to 1. So I have 3 minus, and then if I go from -2 to 1, so let's just do this off to the side here. If I'm doing the integral from -2 to 1, the integral from -2 to 1 is going to be -9 because it's below the axis. So I'm subtracting a -9. So I end up with 12 for that answer. And what they're giving you points for here, 1 point is for the integrand, so it's for putting f prime of t in here. Sometimes I'm sure people put like f of t instead of f prime of t, so be careful you're doing the derivative there. Remember when you take it out of the integral, it turns into just the function. So the integrand is 1 point, the expression for f of x is a point, so having this here is a point, and then both of these you'd have to have correct to get your third point. Okay.